6 from the preliminary exam, and we've got a point P that's moving along a curve in such a way that the x coordinate is increasing at a constant rate of 2 units per minute. The curve's equation is this. And find the rate at which the y coordinate is increasing. So immediately you should recognize that we are looking at a differential equation. Now, what should give you a hint as to that? Well, this word here, rate, okay? Rate is what should give you that. Now, we've got P moving along the x-coordinate, and it's increasing at a rate of 2 minutes per minute, so we say that dx dt is equal to 2. We are trying to find the rate at which the y-coordinate is increasing, so we want to know dy dt. And we also have y equals something here, so we can find dy dx. We can actually find that one. So we know that dy dt is going to be dy dx multiplied by dx dt, and you can kind of see, I hope there, that this will cancel out and this will cancel out, and that will leave you with dy dt, which is what we want to find. Whoops, I've just noticed a mistake here. We want to find dy dt, and that's how we're going to do it. Okay, so I guess our first step in this is to decide what dy dx is. So we're going to differentiate this 5x minus 1 all to the power of 1/2. So I would set up over here that u is 5x minus 1, and therefore du dx is equal to 5. Some people made a mistake here and said it was equal to 5x. Okay, and then y is equal to u to the power of 1/2. So I'm using the chain rule here. Therefore, dy du is equal to 1/2 u, and we're going to drop our power down to the minus 1/2. Then we put it all together. Dy dx is equal to du dx times dy du. So it should be 5 times 1/2, and then we'll have 5x minus 1 to the minus 1/2. Okay, so that's what we should have for this first part of the question. At this point, we're now ready to find dy dt. And that should be dy dx, which I've just found, 5 times 1/2 times 5x minus 1 to the minus 1/2 times dx dt, which we know from over here is 2 times 2. And we could simplify that. That becomes 5, because that 1/2 cancels out that 2. And we could perhaps rewrite it nicely like this. And that's to the power of 1/2. Because it's a negative half, I'll put it at the bottom there. Alright, the final step is at x equals 1. Dy dt equals, and we're just going to insert our values here, 5 over 5 times 1 minus 1 to the power of 1/2. And that equals 5 over, at the bottom we'll have 5 times 1, which is 5, subtract 1, which is 4, square root of 4 is 2, so it'll be overall 5 over 2 is our first answer. Okay, now find the value of x when the y-coordinate is increasing at 5/8 units per minute. So we are going to take our dy dt and we're going to make that equal to 5/8 because the rate of increase of y is 5/8. So we're going to have 5 over 5x minus 1 to the power of 1/2 equals 5/8. And I hope you can see from this that we can therefore say that 5x minus 1 to the power of 1/2 is equal to 8. And therefore we could say 5x minus 1 is equal to 64. Let's have a look. Have I done that correctly? And I think at this point I will say x. I've got to add the 64, so it'll be 65, and so x equals 13. And that is that one completed.